All right, so as I said in the last story we covered, right, about the, look at that, I already forgot, the Phantom of Heilbronn, okay? It was a DNA-focused story. Now, each week we cover an Idaho 4 topic, at least until you guys get tired about hearing about the topics.
Yeah.
You know what I mean? We keep getting asked questions, keep getting asked to go deeper and look into this and look into that, which I love. I love doing it because my favorite part is hopping on premieres and chatting with you guys and then hopping on the live stream after and having an engaging, logical conversation, going even deeper. So I wanted to try and do another expert type topic, and it's super funny because the last one, the wireless one, so many people are like trying to throw tomatoes. How dare you call yourself an expert? Yeah. 14 years doesn't make me an expert. You're right. So this one I am not, though. Okay, I do not know much about it, but I researched and looked into a whole bunch of expert data, right? And the only way that you're going to become an expert in this is going to school for some sort of science, some sort of science degree. So we're going to be touching on DNA. The story about the Phantom of Heilbronn was directly with a major DNA fail, okay? So I found it really interesting that DNA is like the end-all, be-all evidence in any case. And I started wondering, is it really? Because before we went to TrueCrime and before we started looking into touch DNA and trace DNA, I didn't know how unreliable that was. I had no idea that touch DNA and trace DNA is not allowed in most of the world's court systems. I didn't know that touch DNA and trace DNA is not allowed in our own military court systems because of its unreliability.
Yep.
We are actually an outlier here. Now, there are some pros to that and there are some cons to that.
There are.
The cons is the unreliability. The pros is we're seeing a lot of cold cases closed. We're seeing a lot of people who have been proven to be innocent,
Yeah, I
dude.
know.
Like
I
a
know.
lot. So let's dig right into this here. So a DNA focused conversation around Idaho 4 specifically. I want you guys to keep Idaho 4 in mind in this situation, especially when we're going to be going through some of the questions at the end that I will have for myself, I will have for you, and we'll kind of go from there. So DNA. DNA, in evidence is DNA fingerprinting, and that was developed in 1984. And based on everything you can read, it's not a perfect science, but it is law enforcement's preferred science when it comes to crime scenes and evidence for court. It's the court's most reliable science. At least that's what we're perceived to believe, and that's how courts act on it. Now, when I was doing research into this, it was interesting to see how many cases where DNA was brought to court and it is like 10% efficient. And there are multiple examples of cases where they brought DNA and it's only 10% efficient. Meaning that DNA that they're showing could be 1 in 10 people.
What?
Yeah. I bet you guys are like, what are you talking about? I thought that DNA either matched or it didn't. Not how it works. It is done based on percentages. Okay, so let's go through this. So DNA, or deoxyribonucleic acid, is in every cell of every living organism and contains the blueprint for building and maintaining living beings. I think most of us learned that through school, right? So I'm just retouching on the topic. All DNA is made up of 4 chemical bases, and that is adenine, cytosine, guanine, and thymine. These chemicals link together to form base pairs, and that is important. So, and then these base pairs form together long chains of base pairs. Those link up to form strands of DNA. Okay, so those three. That's the three different things that make up that DNA. You have the base pairs that form chains of base pairs that form the strands of DNA, okay? Then within it, it's different combinations of base pairs that form and define different genes that give us different traits, like your eyes, my nose, your mouth, my hair, your skin tone, whatever. You know what I mean? Literally all of our traits.
Thumb, where your thumb goes backwards.
Literally everything.
Yeah.
Everything on you, right?
Yeah.
Anything that when you're a kid and your parents are like, oh, you got that from your mom or you got this from your dad. Like, that's it,
well,
right?
And also
all
the
of
blueprints that make you a person.
Yes, but that's not important in this. I'll explain.
You're right,
so,
it's not.
The interesting point to that, okay, the accumulated human genome contains about 3 billion base pairs. 3 billion of those base pairs, okay?
It's amazing.
But, and this is a huge but.
I love big butts.
And I cannot lie.
Yes.
Okay. Only about 0.1% of that 3 billion of those differentiate one person to another.
0.1%.
0.1%.
Wow.
So, that tiny fraction of 0.1% of the human genome makes us different from each other.
See, we are more alike than we are different.
We are.
No matter the color of your hair, eyes, or skin.
We are more alike in 99.9%.
Yep.
And we are only different in 0.1%. Everybody, all humans.
Yep.
So then obviously that 0.1% is what crime scene analysts and lab techs use for DNA fingerprinting. They don't care about the 99.9%. They only care about 0.1% of DNA to connect a person to a crime. Are you starting to get now how you can have 10% likelihood?
Yeah, it literally means nothing.
That means everything. That means they could have a DNA profile and a DNA profile and be missing the 0.1% of all the important stuff and look at that DNA profile and be like, I mean, this could be half of the world's population.
Exactly. That's why 10% is nothing.
1.1%. Yeah.
You said...
Oh. No, I
10%.
just said half of the world's population.
Okay.
So, hot take to that. While we're on this topic, okay? So, the figure the prosecution gave us was to the octillionth for Brian Kohberger, okay?
Okay.
That Brian Kohberger's DNA was to match the sample.
Are you about to do math?
I am. So, if there's only 8 billion base pairs, and 0.1% of that is what defines our differences in DNA fingerprint, how did they get to the octillionth? It's mathematically impossible, okay? So, our 8 billion and 0.1% of that is 8 million. So, DNA analysts are looking for 8 million base pairs out of the 8 billion that could come out of a person, right?
Okay.
So, 8 million base differences between each person to person. Now, if you multiply 8 million by 8 million, which would give you every known possibility of makeup, right? Do you know what the largest number is that it comes up with? 64 trillion. There are only 64 trillion different ways to make a human.
Okay.
So how did they come up with
that figure?
And the exact statement is, the FBI then used common genealogical techniques to develop a family tree that led to Kohberger. The DNA was 5.37 octillion times more likely to be Kohberger's than a random person from the general population, according to the documents.
Is there another variable that could be added to that you need to calculate into that probability?
Not based off what I could find.
Okay.
If they're looking for 0.1% and each human has roughly 8 billion base pairs, okay, that leaves 8 million. You times that by itself to come up with any of the possible ways that those 8 million pairs could be put together, and that is 64 trillion. So 8 million can only make 8 million other different pairs or whatever in 64 trillion different ways.
It's not 16 trillion?
No. 8 times 8 is 64.
Oh, yeah, you're right.
So.
Yeah, you're right. That's so dumb.
So. 5.37 octillion times more is multiple, what is that called? The comma. It's not the decimal point. It's the multiple. I don't know. Whatever.
I'm not the math whiz
yeah,
here, okay?
Multiple zeros to the left. It's not possible based on everything I'm seeing. However, like I said in the beginning of this video, though, you guys, I am not the expert in this stuff. This is all research that I looked up. Is it possible that I could have a flaw in what I was doing research on? Absolutely. This math is right, but like Malia was saying, is there another variable? Is there something else that could make it go to 5.37 octillion times, you know, to be Brian Kohberger's? Because everything I'm reading doesn't say that. What they should have said, if it was perfect data, was 64 trillion. That is perfect data.
That's so weird.
Yeah, it's super weird. It is super strange.
I feel like I have heard people question that octillion number before.
Yeah.
I just don't
And the fact that it's not even a real
was.
number. Yeah, it's not a real number. So the octillion means it is 8 sets of zeros. Mm-hmm. So I don't even remember what a trillion is. So million is, you know, you're in the 3rd set. Billion is you're in the 4th set. Trillion is the 5th set. And then you have the 6th, 7th octillion. That's how much more they're trying to say. When based off the math I'm seeing, it's only possible for roughly 64 trillion.
Yeah, but don't you think they just came up with a totally bogus number? Like, people everywhere that know about this would be like, what are you talking about? That's not even possible. I feel like there has to be another variable that they're factoring in, but I don't know what that could be according to what you just said. Like, I don't know what else that could be.
I mean, don't get me wrong. I am not, like, betting my life on this number.
I know you're not.
There's only one thing I know in life, you guys, and that is that I know nothing. So if you're an expert in this and you're watching me right now and you're like, this dude is an idiot, help.
Yeah.
Like, tell me what you know, because I didn't go to school for this. So all I have is the information that I can pull between Google, DuckDuckGo, science textbooks, things like that. And I know math, so when I'm trying to come up with these math figures where these analysts really only can test up to 0.1% of the total base pairs that are in a human body, that's what it comes up to. You times it by itself of the 0.1% of 8 billion, and then that gives you the total different factors available, right? So 64 trillion, which when it comes to humans on Earth, we're nowhere near that number. Nowhere near that. That is such a huge number. Like, it's easy to say 64 trillion, but that's insane. There are no trillionaires on this Earth. Like, it is a super insane number.
Yeah, it is. And like we said, like, we prefaced the podcast with saying, like, thought-provoking conversations are goal. It's a talk show.
Yeah, not expert.
Right.
Everyone just liked talking about some of the expert topics, so we'll try a different one, you know?
Yeah.
I might totally crash and burn and fail, and you guys are sitting there laughing. Ha, ha, ha. You know? But, okay, back to DNA. So, when samples are gathered, like blood, saliva, or, you know, other bodily fluids, experts gather that up and analyze it, comparing it to another sample. So that other sample has to be there. And I feel like we all understand how they came up with the sample for Brian Kohberger by tracing his heritage and tree through the genealogical information in the data analyzing websites or whatever.
Not his DNA.
Well, it directly tied back to his family members, his dad's, right? And
Yeah.
they were able to gather his dad's to create this profile, which
right,
ultimately
right.
led them to taking his DNA and then making the match on that all together. But what I think is the important part here when we're talking about like how they gather this DNA is experts gather it and analyze it. So when I was watching this, and I watched people that like believe 100% that DNA is concrete, and I watched people that doubt it with certainty that it's not concrete. Their biggest concern is the person element. So their biggest concern is, could this DNA be mixed, cross-contaminated, fraudulently gathered by any human element? Absolutely. Not only, and just think about this for a second, not only are you know, with your little swab at the crime scene getting your DNA, if you're not fully covered, you could have cross-contamination. You could also have cross-contamination on the crime scene. You could be picking up multiple different people's DNA. You could be picking up 5 different people's DNA, right? And you put it in your little glass tube, whatever, your sterile tube. You take it back into what is, we hope, a sterile lab. You pull it out of that thing where you have multiple other people and multiple different DNA tests and agents and profiles being tested all at once in one area. That's another possibility for cross-contamination. You know, we brought up a good question in one of our recent live streams where we were asking, when that DNA evidence, when that DNA test, okay, is at the lab, right? Who watches that? Does that DNA test stay under a camera? Is there ever time that DNA is by itself? That leaves a lot of room for opportunity for flaws, you guys. Whether I'm not going full tin hat here. I'm saying it could be cross-contaminated, messed with, changed, damaged, any of these things, any of these honest things and dishonest things that could create a flawed outcome and result by any of these situations that we're talking about. It could happen in any of them.
Like, okay, so you talked about cross-contamination. Literally the perp, okay, the suspect's hands could be cross-contaminating their own DNA on the knife sheath because they touched somebody's hand or they touched something somebody else touched, and they have other DNA on their hands when they touch something, and it will mix with their DNA from their own hands. And, you know, then you have the instance of, well, Brian was like a really good criminologist student who worked with experts in the area. Okay. Okay, did he know anybody who worked at ISP?
I
Did
was
he
going to go
work
there
with
too.
anybody that worked at ISP?
Could his DNA be in any of those labs? Has he
Yep.
been there? Has he worked with somebody? Could there be some sort of cross-contamination in the kit, in the people, in the lab? And I'm just trying to think of honest mistakes. There's a
Yeah.
whole realm of possibilities for dishonest
Yeah.
mistakes. Almost in every situation where I was doing research into DNA, the reliability, the profiles, the chance, the likelihood, the questionability in a court of law, in all of them, they talk about dishonest situations, giving examples for multiple
Yep.
cases. And look, here's a good example here. So, I guess we'll get through this. So the more distinct matches increase that percentage of likelihood they have a match, or decrease the likelihood based on those pairs. But shows like CSI make DNA sound like it's the solution to all things crime and law enforcement. Depends on this too. At the same time, they want people to believe this. So
Yeah.
an example of that is Josiah Sutton, okay, was convicted of RAPE because of a crime scene expert testified that they had an exact match of his DNA that was recovered at the scene. Josiah Sutton then went and did 5 years of prison time before getting a new expert, an attorney, to fight to get his DNA tested again, because a lot of times they don't easily test it again in a lot of different situations. So he did 5 years in jail while waiting for the second round. Now, the second round was conducted, and he was less than 10% of a match.
Oh my gosh.
Less than 10%, and he was let out, you guys. 5 years of his life lost. Who knows if he had a career? And that the best thing that they could come up with is that that crime scene expert thought he was trying to help out police in that situation. That doesn't help out anybody, okay?
What? He was trying to help out by... What, did he lie?
He lied 100%.
Oh, yeah, he said there was an absolute
Whether it was cross-contamination
match.
or
Okay.
whatever, he said it was 100% match, and it wasn't. And DNA is very rarely ever 100% match, which, going back to that octillionth argument, right? So DNA has exonerated over 600 people in our court system since 1989. The Innocence Project alone's clients are over 200, and it has saved 35 people from death row.
Wow.
Yeah.
Whoa.
Yeah. One thing that's interesting, though, is that many states have post-conviction DNA laws that restrict people from being able to be tested again and be exonerated. Yep. Ridiculous.
What?
I know.
That's
feel like
not okay.
I feel like if it's a pay thing, they should let family pay for it to be tested again, something like that. Okay.
No, they should just allow it no matter what. Who cares about the money? If there's...
Yeah, but if
Come
you could just
on.
be tested until somebody finds a flaw, because people are involved and people are flawed, you could be a prisoner and be like, hey, I need to order my monthly test, and just test DNA that convicted you every month until somebody says, oh, not a match. You know what I mean? Like, there's got to be restrictions to it. There has to be.
That's fine, but, like, I don't know. It sounds like it's a bit harder than it should be, though.
It is. It is absolutely harder than it should be. So, I have two very interesting tests here, okay? So, easy transfer of trace DNA and how that contaminates a crime scene. Okay, this was a study posted in phys.org. And this was at the University of Indianapolis, and this shows secondary transfer of human DNA through intermediary contact. What they do is they take two people, and they have these two people shake hands for 2 minutes, okay, an extended period of
Okay.
rubbing and whatever.
Just rubbing hands.
A shaking hand. So I don't know. I just was thinking of why that could benefit for 2 minutes. But just shaking, like just shaking.
Oh, just like this?
Yep. And on every single time that person went to go grab the next item, there was a presence of secondary DNA every time.
Okay.
Every time.
That's pretty good.
Yeah. That is super interesting, to the point where the student goes on to say it's super scary. Analysts need to be aware that this can happen, and they need to be able to go into court and effectively present this evidence. They need to school the jury and the judge that there are other explanations for this DNA to be there. The experiment designed by Cale and Earl asked pairs of volunteers to shake hands, for which they had handled knives that were later swabbed for DNA. They did this in 100% samples, but it's 85% of the cases. DNA from the person who did not directly touch the knife was transferred in sufficient quantity to produce a profile. In 1/5 of the sample, that person was identified as the main or only contributor of DNA. That means that after they shook hands for 2 minutes, that person that didn't touch the knife, in 1/5 of the samples, the guy went and grabbed the knife. This person that never touched the knife left a single source DNA on that knife. Weird. Right? That's scary. That's super scary. Terrifying.
And it's a single source on the knife sheath.
Yes.
Okay.
So, and then there's another study, and I will link these studies, you guys, in the video so you guys can see it. But there's another study where they took 4 people, and they did this like 4 or 5 different times, and they rubbed hands. They put the left hand on a glass plate, right hand picks up knife, stabbing of a box, and then they place the knife on the paper, and then right hand on the glass plate, and then right hand on the glass plate. And then they just repeat this. So person 1 does this, then person 2 does this, then person 3 does this, then person 4 does this. When they get to the test results, okay, every single person that touched it is on every single test. Every single one.
Suspected that was going to be
the first one that does it is still present on every test. Now, it is the lowest amount of DNA found, as you can see here. Person 1 is purple, right? Person 2 is red. It gets a little bigger. Person 3 is green. Person 4 is blue. And then yellow is unknown source. So all of them are on there every time except... Well, no, even 2. There's a tiny, tiny, tiny bit of red. Yeah, they're on there every time. Every time. So DNA can be transferred.
And then transferred again.
And then transferred again, yes. Yes.
Touch DNA specifically,
Touch
too.
DNA specifically.
Yep.
So, but I found this stuff super interesting. It just left me with a lot of questions. And I would love to know what you guys think of this, because I don't want to go full tin hat with this. But like, people, even experts on YouTube, I feel like we're seeing some bias there. They either try and make it seem like touch DNA and trace DNA is as confident and successful as direct DNA, and then you have people that try and make the touch DNA and trace DNA seem like a joke. Again, going back to real life is in the middle of those two things, okay? Brian Kohberger's DNA is on a knife sheath in the house where the crime took place, attached to the cover of what they guess is the murder weapon.
Yeah.
And there's not another piece of DNA on there according to the test. Could there have been, and it was left off, knowing that a single source DNA looks more guilty than multiple DNA. It could. People have also said, hey, this could be staged. Look, weirder things have happened too. But could he have legitimately left this on site there? Yes, that's a real possibility too. We can't ignore any of it. So, looking at it from the standpoint of the court, the defense is going to have to explain this DNA no matter what. They have him and his DNA, not him, they have his DNA on the crime scene. And it is now the defense's job to explain in a reasonable outcome why, or a reasonable explanation of why and how that could have got there. And make that explanation sound more plausible than the prosecution's explanation.
Right.
And there's no way around that. No matter how we feel about this DNA evidence, no matter how much trust we have in the touch DNA evidence, this is the facts. This is what it is. Even if it was put there in a manipulative, setup type way, this is what it is. And there's no way around that. So,
no,
do we feel like this DNA was handled correctly? I know I have questions of, is the test ever left alone in the office? Why did they not get this DNA on the first run? Was what they said true? Is 5.37 octillion in a real number for an outcome of likelihood of being a person when it comes to DNA? Are they going to be able to prove a flaw with the handling? You know what I mean?
Yeah, I'm so curious if he ever visited the crime lab now.
Me too. I'm more curious how the defense plans to explain this, though.
Yeah, for sure. Because, I remembered that I heard something about him having access to the crime lab. Well, they're saying it's the databases, but it would be so interesting to find out he actually went there.
It would be.
But also, if you say it is what we were talking about with Sandra Ladd, okay? Where, maybe somebody who killed her and the Jutons became of age and then went to college in that area. Say they're in one of Brian's classes.
And they didn't like him because he's a harsh grader on men and women.
Or it's just touch DNA.
Yeah.
From touching anything that has to do with Brian.
Yep.
Maybe he shook hands with him that day or the day before, or I don't know, graded a paper. I don't know.
Agreed. I think there's a lot of possible different outcomes, and it's going to be the defense's job to figure out what is the most plausible and believable by a jury of his peers.
Yeah.
And I think they have a big task ahead of them, no matter what. Mm-hmm. They're either going to have to prove that this DNA profile is full of it and it was mishandled, whether it was mishandled by creating the profile that they then attached to him, whether it was mishandled by there not being DNA in the first test and all of a sudden there was a second test, so the only way that DNA could have got on there for the second test is cross-contamination. You know what I mean? They're going to have to come up with some kind of plausible reasoning, and sometimes it takes a little bit of an investigation for them to figure this out. Yeah. I'm curious what that answer is.
I am too. I'm very curious what it is. Kind of sucks having to wait so long now.
It does. It does.
But
I'm curious what you guys think too. I think it's helpful when we look at this logically and think that if we think this is manipulated, if we think it's flawed, if we think it's fraud, if we think it is set up, if we think it is legitimate, all of those things, right? We got to look at it from the standpoint of the defense team and think, okay, well, how are they going to manage this, though? Because this is the story.
Yeah.
They're either going to get this case thrown out where it doesn't matter. They're going to get this DNA thrown out where it doesn't matter. They're going to be able to investigate the DNA, find the profile was made in a way that goes against what the rules and regulations are. in those DNA accounts or whatever. I forget what the name of that is right now, but yeah, I'm curious.
Me too.
Let us know what you think.
Super interesting, though. Yeah, let us know what you think about it. What your theory is, how the defense could refute the DNA evidence.
Yeah, absolutely. Absolutely.